here, you guys at home will see our first couple of examples, what we're working with today. There we go. So I'm going to multiply coefficients, and then also we're just going to multiply each variable. Okay. Here, let me zap you there, Charlie. Thank you, sir. So look at example 1 here, part A. I'm going to say 3 times negative 4. Like I said, it's super simple, right? That's going to be negative 12. X squared times x cubed. That's where we get to use our new exponent rule. Paul's going to tell us what that is. X to the... Yes, speak up, Paul. Add the exponent. So we're going to have an exponent of 5. Very good. Because look at it. It's like x squared is x times x cubed is x times x times x. So, of course, we got 5 x's sitting right there. So that's x to the 5th. All right, multiplying monomials is super simple. You just multiply the coefficients, and you multiply each variable. And if there's multiple variables, just take it one letter at a time, okay? Now, 5/6 times 12 over here on this second example, 5/6 times 12, I could say 5 times 12 is 60, divided by 6 is 10, or we could cut 6 into 12 and get 2. 5 times 2 is 10 there. Question, Tiago. So when we said multiply coefficients, we multiplied 3 times negative 4 and got our negative 12. And then when we said multiply the letters together, I'll color code it here. We multiplied those two and we got our x to the 5th. Does that make sense? All right, fabulous. And similarly over here, that's exactly what we're going to do with this second example. We're going to multiply 5/6, right? 5/6 times 12. What did we say that equaled? So that's going to equal 10. Awesome. And then we'll multiply x cubed times x. Lewis, what's that going to give me?
X to the 4th.
Throw some fingers up in the air, Lewis, if I can't hear you. X to the what?
The 4th or the 3rd?
Lewis, I still can't hear you. You got to throw some fingers up in the air, bro. X to the 4th. Very good. I'll fix I got a setting I need to adjust here on the fly. And then last but not least, we got y times y squared, which Alex is going to tell us is y to the 3rd power. Very good. And again, just kind of color coding it. The 10 came from the coefficient multiplication. The x to the 4th came from those two x factors. And then the y to the 3rd came from those two y factors. So real straightforward look at multiplying. What do we call those kinds of polynomials? One-term polynomials? A monomial times a monomial. Very easy. And as you look in blue, I've gave you those instructions. We're just going to multiply coefficients, and then we're going to multiply the variables, and we'll use our variable rules. All right. Questions on how that first example worked out? As I'm going to adjust my speaker settings here. All right. Let's take a stab at number 2. Number 2 is going to be just a little bit different. Example 2 is going to be where I'm multiplying a monomial times a polynomial. Okay. And as I say in my note there in blue, that's where it's going to be using the distributive property. Think about it like this. Remember, if I was going to distribute some papers to you guys, I would pass one out to everybody. Okay. And so if I am using the distributive property here, display audio. There we go. I should be able to hear you guys at home now. There we go. If we're using the distributive property, then I like to draw a little bit of some arrows. Okay. Nate, help me do this distribution here on example 2. We're going to do, Nate, you'll just do that first term for me. All right. What's negative 2y times positive 4y squared? Negative what? You got to do 2 times 4, bro. There we go. Negative 8y to the 3rd. I like that y to the 3rd because we added our exponents. Jack McBee, help me with my second one there. Negative 2y times positive 3y. Negative 6y squared. Fabulous. And then who wants the last one? Who wants to distribute the last one? Joey, go ahead. Pardon? Plus 10y. Fabulous. Again, just distributive property, nothing too hot and heavy, right? All right, but we're doing, again, coefficients times coefficients, variables times variables, using our basic exponent rules, okay? You guys try out part B on your own here. You guys try out part B. And again, what we're doing is we are distributing, we're multiplying that whole monomial term times each individual term right here. And that's 1, 2, 3 terms. That's a monomial times the trinomial. So my result is going to be a trinomial. I need to see 3 terms. And what I'll do is I'll call on 3 individual guys to give me those terms. We had a very interesting morning at the Morgan house. You'll know that today is December the 1st, right? What happens on December the 1st? Herman Sparkle showed back up. Herman Sparkle is the Morgan family elf. He showed up, he was hiding in one of the potted plants, and he was wearing the vest that Betsy, my 7-year-old, sewed for him last year. So when she saw that, she was almost in tears. She was so excited. And so it was a good morning, good way to start the day off. Good old Herman Sparkle. He's a troublemaker, Herman is. Herman, last year, he popped a bag of popcorn and watched a movie in the middle of the night and left the popcorn all over the den. It was very frustrating for me because I had to clean it up, but the kids thought it was hilarious. One time he was dental floss ziplining from one of my deer mounts to the Christmas tree. He had tied up the dental floss on the deer's antlers in the Christmas tree, and he was we caught him in mid zip line. And of course the kids loved that too. So December's an exciting month. Gotta love it. Gotta love it. All right, let's see here. We're gonna go Will, and then we're gonna go Andrew, and then we're gonna go Reed. 1, 2, 3 each term, please and thank you. All right, so Will Edwards, hit me up. What's 3x cubed y times x squared?
I think I did it wrong.
All right, so I like the 3. Let's start there. If I got 3x cubed y times x squared, check this out, boys. What we're going to be able to do is we're going to be able to use our commutative property of multiplication. Right, Charlie, what's 3 times 5? What's 5 times 3? Right, that's an illustration of commutative property, just 2 random numbers multiplied. The order doesn't matter in their multiplication, does it? So for us, we got 1, 2, 3, 4 factors right here. The order isn't going to matter. Okay? So I could say, and this, by the way, is just like 1x squared. I could say 3 times 1 times x cubed times x squared times y. All right? So I could reorder my factors. Everybody in the brother knows 3 times 1 is 3. All right? And y, he doesn't have anybody to multiply with. He's kind of sad and lonely. But then we'll kick it back over to Will Edwards. Will, how much x do I have? There you go. Good. X to the 5th. And that's what we have after that first distribution. Does that make sense, fellas? Okay. All I'm doing is I'm matching up the letter x squared with the other letter, x cubed. Match your variables and multiply. All right, let's take the second one there, Andrew. As you multiply coefficients, keep the signs straight also, by the way. I'll give you that admonition.
Negative 24x y squared.
Negative 24x to the 4th y squared. Fabulous. Couldn't have said it better myself because, again, 3 times negative 8, that's negative 24. X cubed times x, that's x to the 4th. And then y times y, of course, is y squared. All right, Reed, you got my last one? 3x cubed y cubed. Fabulous. All right, so what we'll do is, let me shrink this guy down here. And what do we got? We got 3x to the 5th y. X to the 5th y. And that will be our answer. All right? And again, that's a trinomial, right? We had 1, 2, 3 terms. So when you look at distributing a monomial times a polynomial, okay, it's very straightforward if you just take it one term at a time. Don't rush. Just take it one term at a time, multiply coefficient times coefficient, variable times variable, and it's pretty straightforward. Now, What we're about to get into is what happens. We've done a mono times a mono. We've done a mono times a poly. What do you think we're about to do? Jake, you asked me about this earlier. A polynomial times a polynomial. In other words, many terms times many terms. We're going to start small. We're going to do a 2 by 2. All right, we're going to do a binomial times a binomial. And this is where, again, we can use this process of distribution. We can say that, you know what, look here in green. There's 2 ways to look at this. We could say that the quote thing out front that we are distributing here, instead of a monomial, it's going to be a polynomial. So we're going to multiply it times both of those terms. We're going to take y plus 5 and we're going to multiply it times y. So we got, whoops, elbow hit the trackpad there, excuse me. We're going to say y plus 5 times y and y plus 5 times 8. It is as though there's this big fat, like if I had written it up this way, a, right, times quantity y plus 8, and I said, hey, George, distribute that. What would we say here in red, George? A y plus a 8. Absolutely right. That's essentially what we've done in green. We've taken y plus 5, treated it like our quote a there, and just dumped it in. Now there's more work to be done, isn't there? There's more work to be done. What we're going to do is, I feel like I'm yelling at y'all. Let me turn that down a little bit. Is we're going to distribute a second time from the back. Okay, we're going to distribute a second time from the back y times both of those terms and 8 times both of those terms. Let's see what we get. All right, Alex, what do I get when I distribute y times both of those guys up front here? Plus 5y, fabulous. Jake, what do I get when I distribute 8 times both of these guys here on the second bit? 8y plus 40. And then do I see, Tiago, any like terms that I could combine? All right, which 2 go together? And they come together to give you what? 13y. Ooh, and I love how he did not change the y to, like, you know, y squared or something kooky like that. Sometimes I'll get students that will do that, and that's no good. That's not what we want to do. So a couple notes. First of all, if you like the distributive property, then multiplying a bi times a bi, just distribute that binomial as one entity times both of the second terms, and then redistribute a second time as we did here on the second level. You'll notice that how many terms did we get all together before simplifying? We got 4 terms before we simplified. A bi times a bi yielded 4 terms. What do you think a tri times a tri would yield? 9 terms. Think about it. The first term of my first trinomial multiplies by 1, 2, 3 things in the second. The second term multiplies by 1, 2, 3 things in the second. And the third term multiplies by 1, 2, 3 things in the third. So I've got 3 sets of 3. So a 3 by 3 would yield 9 terms before combining and simplifying. Now look over here, and I notice 5y and 8y go together. That's not a coincidence. Okay, you're oftentimes going to be able to combine a couple of terms. Those are both linear terms. It's y to the first power. And so it's like if I went to the grocery store and I got 5 rotisserie chickens, and then the next day I went back and I got 8 more rotisserie chickens. I really love rotisserie chickens, I guess. How many would I have altogether? I'd have 13 rotisserie chickens. Doesn't all of a sudden become 13 packs of bacon. Okay, which would also be nice, by the way. It doesn't become 13, potatoes. We don't change what it is. We just change the C word. Just change the coefficient. Now, there's a second example up here, and we're going to look at this second example a little bit differently, okay? We're going to use an acronym, which is a process called FOIL. Now, how many of you guys have been taught FOIL before? Anybody? Okay, one guy. Now, FOIL is an acronym that we use to demonstrate what we just did in green, just a little bit different way, different flavoring for you, okay? So today you're going to learn about FOIL, okay? Now, FOIL is an acronym that stands, write this down, I don't have it on the screen. It stands for first, outer, inner, and last. First, outer, inner, last. And it's a way for us to visualize the multiplications that we just did. How many multiplications did we do over here? We had 4. The word foil has 4 letters in it. Oh, that's not a coincidence, is it? There used to be a great country song that I loved by a group called Shenandoah. All right, Shenandoah said, "Barbecue chicken in aluminum foil, just enough money for my gas and my oil. Don't need your fancy caviar. I just assume have you, just the way you are." Oh, they knew how to write a song back in the '80s. Let me tell you. But FOIL. Anybody, y'all like cooking barbecue chicken? Anybody? You guys? We started recently. I'm very proud of my boys. I got a couple guys that are I guess inaugural members or whatever. I don't know. Whatever you call it when you start something new. But they started a barbecue club here at Christian Brothers High School. All right, we got lots of different clubs. You know, like I do mountain biking club, for instance. These guys started a barbecue club, and so they get together and cook stuff. They roast and smoke and grill meats. And so before the Thanksgiving break, they had they had a dry rub contest, and they had a sauce contest, a hot sauce contest. And so they were out there grilling and smoking. And I asked them, I said, do y'all use the Texas crutch when you're cooking? And they looked at me like I was crazy. You know what the Texas crutch is? Anybody heard of the Texas crutch? It's foil. You wrap that bad boy up in some foil, especially if you're cooking something like ribs. You know, you put the ribs on the smoker, and you let them soak in that smoking flavor a little bit. And then you wrap them up to keep them what? Keep them moist. They're going to be on the smoker. They're going to be warm. But you wrap them up in that foil, and you let them finish cooking in their own juices. Ooh, I could talk meat all day, but hey, we got work to do. FOIL. What did F stand for again? First. So what that means is we're going to multiply the first term of each binomial. The first term is 4y and 2y. So when we multiply 4y times 2y, we get 8y squared. All right? Bless you. When I multiply, this O stands for outer. That's the 2 terms. Watch my hands here. That's the 2 terms that are on the outer rim, so to speak. The outer reaches. The ones that are on the outside. That's 4y times negative 5. 4y times negative 5. Now, what's that going to be? Negative 20y. I'm scooching him over just a little bit. You'll see why in just a second. All right, what does I stand for again? Inner. All right, the inner 2 are right there. 3 and 2y. Those are the ones that are on the inside, aren't they? So we say 3 times 2y, that's 6y. 3 times 2y is 6y. Again, I scooched him over. You'll see why in a second. And then last, my L is 3 times negative 5. 3 times negative 5, and of course, that's going to be negative 15. And I scooched him way over. Again, you'll see why in just a moment. Now, once it's all said and done, FOIL, 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 foil. Once you've done your foil, you're just going to tally everything up. You're going to combine everything. And based on like terms, sorry, but there's only one quadratic term, so he's by himself, 8y squared. But there's a couple of linear terms, so we want to combine those two. Okay, there's a couple of linear terms. Paul, can you combine them? What's negative 20y and positive 6y tally up to equal? Negative 14y. And fabulous again, he did not change the variable. He just changed the C word. Just changed the coefficient. Very good. And then, of course, we just take negative 15 down. And that's all she wrote. That's your FOIL problem. And I love FOIL. FOIL's the way to go. I'm going to tell you, FOIL's the way to go. Don't mess around with the distributive properties. Just FOIL it out. Okay? And eventually, what we're going to do is we're going to get to the point where we can FOIL stuff in our head. You're like, no, we went, no way. I'm going to have to write it down. Bull malarkey. You're going to be FOILing in your head before you turn around. Okay? I will have you guys FOIL masters. You'll be grill masters. Be ready to join that Christian Brothers meat cooking team. What did you guys do over the weekend? We cooked meat. What's y'all's favorite kind of meat to eat? You guys have a favorite? Steak? Oh, that a boy. I bought me some steak yesterday. I thought, you know what I'm going to do? I'm going to let it marinate overnight. I'm going to grill some steaks tonight. It's going to be delicious. What's your favorite cut of steak? You got a favorite cut? Not really. All right, so you got your ribeye, you got your sirloin, You got your T-bone. T-bone? Anybody Seinfeld reference? No? Okay. But my favorite is the filet. Oh, mama, it's juicy, it's good. It's got, sometimes you wrap bacon around it, George, you know what I'm talking about? Oh, yeah. Just don't eat the toothpick, okay? One time my mom would cut into a filet and she ate like half a toothpick. What's the problem with eating half a toothpick? It's sharp. So when it comes out the other end, it's not going to feel very good. And so I always remember that. When she told me that one time, I was like, "Oh, Mom, that's terrible." But I've never eaten a toothpick, thankfully. All right. Now we just walked through up at the top of your screen. We just walked through this process, so you guys don't really need to focus much on that. But what I do want you to see, what I got highlighted right there. I do want you to make a note that oftentimes when you're foiling, the O and the I go together to combine to give you like terms. Oftentimes that is the case. Not always, but oftentimes. Okay? The oi oftentimes comes together. Let's see what it looks like down here with example 4. All right. Let's just go across the back row. We'll go Joey, and then Jack, and then Luke, and then Charlie. Y'all do FOIL for part A here. Joey, what do I get when I multiply the first times the first? Very good. N cubed. All right, Jack, you got the outer. Negative n squared. Fabulous. Luke, you got your, I might have said inner a moment ago. I should have said outer. If I didn't, apologize. Luke, what do I do when I multiply the inner? Or n. Let's see how easy this is, fellas. This is cake right here. Num, num, num. Charlie, what do we get? -4. A little slow on the uptake there, Chuck. Make sure we're paying attention. So we got those 4 terms. Can I combine any of those terms? I see no like terms there. You know, I see a cubic, a quadratic, a linear, and a constant. Those are 4 birds of a different feather, and they are not going to flock together, okay? So we keep them separate. That's actually our full answer right there. We weren't able to combine any like terms. Like terms is the same variable or variables raised to the same power or exponents, okay? Very good. Now look at part B. Part B is a different story altogether because we will be able to combine some like terms on part B. Okay, and I hope I'm not moving too fast for you guys, but look, these FOIL problems are like a dime a dozen. Okay, we ought to be able to run through them quick. So we got 3pq times 6pq. Okay, 3pq times 6pq. Again, that's a mono times a mono, so we just do coefficient, variable, variable. Andrew, what do you think we'll get here? 3pq times 6pq. Perfect, son. Well done. P squared, Q squared. All right, let's see here. Tiago, you want to take the O, the outer? Fabulous. All right, let's see here. Who's got the inner for me? Who's got the inner? Jake? 30PQ. And then how about my last one? Alex? -55. You guys are picking up on this very well. -55. Now, I did something interesting right here. What did I do? Like, with regards to how I wrote it up. I stacked them up. I stacked up my like terms. And did you notice which 2 went together? The outer and the inner. They all, look at the highlight. They often go together. So we stack up like terms. Here we got 18p squared q squared. Sorry, he doesn't have anybody to go with. Down here we got lonely -55. He doesn't have anybody to go with. But Lewis, stack up those middle 2 terms for me. Tell me what I get.
You get -3pq.
Perfect. -3pq. So when I do a FOIL problem, fellas, it's just as simple as FOIL, 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 FOIL. The OI oftentimes goes together. Okay, we take our time. A by times a by yields how many terms? 4 terms. Very good. All right. Somebody made mention of it earlier that we've got some homework. And what I'm going to do is I'm going to cut it off here for our new stuff here, this lesson. But what I'd like you guys to do is check out Delta Math. There's an assignment up on Delta Math for multiplying polynomials. There's an assignment up on Delta Math for practicing your exponent rules. You guys ought to be practicing until the cows come home, okay? Who that? Is that Harlem?
Yes, sir.
Hey, Harlem, how you doing? So log on, do your homework. It's not anything that I'm going to take up for a grade, but you know, Harlem, you remember doing FOIL last year? Little FOIL? Heck yeah. All right. You guys, good luck on your pre-ACT today. Y'all stay warm, stay healthy, and live Jesus in our hearts. All right. Thank you so much, fellas. I will see y'all on Thursday. Mm-hmm. I was telling them about our barbecue club.